Hello and welcome to 7.6 Notes. So in 7.5 Notes we went over the tangent ratio, and today we're going to learn two more, the sine ratio and the cosine ratio. So if we let triangle ABC be a right triangle with acute angle A, then the sine of angle A and the cosine of angle A are defined as follows. So sine is equal to opposite divided by hypotenuse. That's the key word there. Sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. Okay, cosine is adjacent over hypotenuse. And a picture that is worth 1,000 words, as they say, would be here. So if we're talking again about the sine of A, then we would put our eyeball or a perspective from A. And as far as A is concerned, opposite is BC. That's where you get the BC from. It's opposite angle A over the hypotenuse. And the hypotenuse is always the hypotenuse. It's AB. So that's where you get the AB from. Okay? So in terms of angle A, again, from the perspective of angle A, opposite over hypotenuse would be BC over AB. Cosine, however, has a slightly different definition. It's adjacent over hypotenuse. Cosine is adjacent over hypotenuse. So if we're talking about the cosine of angle A, we have to talk about the leg that's adjacent divided by the hypotenuse. So in other words, it would be AC, because AC is adjacent, over the hypotenuse, which is AB. Okay? So that's the definition of a sine and cosine ratio. So how do we keep the trigonometric ratios straight in our mind? Well, we can use this little mnemonic device. And that mnemonic device is to think of a beautiful, mythical island nation called Sokotoa. It's a beautiful, yet mythical island, Sokotoa. And on this island, the S stands for sine, and the sine is opposite over hypotenuse. And cosine is the C. Cosine is adjacent over hypotenuse. And then the T stands for tangent, and the tangent is opposite over adjacent. So we have the mnemonic Sokotoa. Beautiful, mythical island, Sokotoa. Sine stands for opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And I will let you write that down on a quiz or test. Like you can write that down on the top of a quiz or test as soon as it's handed out to you. You write down Sokotoa, and then you can remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so that mnemonic device will probably come in handy for you. Okay, so a typical problem you'll get is like this. Use a sine or cosine ratio to find the value of x and y. So first let's try to find the value of x, okay? The value of x. So in relation to my 32 degrees, okay, I would put my eyeball right here at 32 degrees. And in relation to 32 degrees, I know that I need to find out what x is. And x is my opposite. And then I don't have any information about my adjacent. I just have information about my hypotenuse. So all I know about is opposite over hypotenuse. So then you would use Sokotoa to find out which ratio I'm going to use. Well, I know I'm not going to use the tangent ratio because the tangent ratio does not involve the hypotenuse. Okay, and I'm going to have to use the hypotenuse value because 18 is my hypotenuse. So it's either sine or cosine, that's for sure. And again, I want to find my value for x, which is opposite over hypotenuse. So that must mean that I'm going to have to use the sine ratio. So the ratio that you use is always going to be defined by what's given to you. If you have values for opposite over hypotenuse, for example, then you're going to use the sine ratio. If it's adjacent over hypotenuse, you would use the cosine ratio. If you don't have any values regarding hypotenuse at all, and all you have is either an opposite or an adjacent side, and you need to find the other one, either the opposite or the adjacent, then you would use tangent. So again, it's dictated by what you know and what you're trying to find. In this case, it's the sine ratio. So I'm going to be using the sine of 32 degrees. Okay? So, moving right along, the sine of 32 degrees is equal to the opposite over the hypotenuse, which is x over 18. And then the sine of 32 degrees is 0.5299. You would just plug that in into your calculator and get 5.299 is equal to x over 18. And then solving for x, you multiply both sides by 18 and get that x is equal to 9.54. And then to find the value of y, again you have to go back to your SOHCAHTOA. So I'm going to go SOHCAHTOA again. And I'm trying to find now my value of y. So in relation to the 32 degrees, if my eyeball is there, I know something about y, or I'm trying to find my y, which is my adjacent. Adjacent. And I know about my hypotenuse. Oh, hypotenuse. So I must use cosine. So in this case, cosine of 32 degrees is equal to y over 18. So, moving right along, the cosine of 32 degrees is equal to y over 18, adjacent over hypotenuse. The cosine of 32 degrees is equal to 0.8480, so that equals y over 18, and then solving for y, I multiply both sides by 18, and I get that y is equal to 15.26, okay? Both values are rounded to the nearest hundredths place. So that's how you use your sine and cosine ratio. And that's the end of today's lecture. Again, as usual, if you have any questions or concerns, or you need any clarifications on any of these concepts, please feel free to contact me, and it would be my pleasure to help you. Okay, bye-bye.